Right, I'm starting the recorder here. I just installed this little application here to figure out how much resources I'm using out of this computer. And according to this, I'm using 1.1 gigabytes out of 3.8, which is a lot. I mean, that's a lot more than what I expected. So let's go ahead and get started. It is 10:30 right now.
That's with the recorder going though, right?
That's with the recorder going. The recorder is not just recording, it's actually transcoding at the same time. So it's not just recording the voice or the images, it's actually doing transcoding as we speak. And that's why the CPU load is kind of high, because it's doing transcoding as it is recording. So but it's not too bad. And that's why I never understand why people would need more than 4 gigs of RAM on their computers. Why would anyone need more than 2 gigs of RAM?
Because running a virtual machine takes a lot of resources.
Yes, running virtual machines would be one. All right, in the previous class we were talking about open source projects, which I think is relevant to this class as well. So I'm going to start with that. It's a little digression from our usual topic, but I do want to kind of go over the concept of open source. How many people know what open source is about? All right. So, the question was, and I found that question to be a very interesting question, so I want to kind of bring it up in this class as well. The question was, how do I get involved in an open source project? Okay, that was the question. So I'm going to go back a few steps here. So the first thing you want to do, is to find out, how an open source project is hosted. A lot of open source projects are hosted by SourceForge, which is a free resource to people who want to create open source projects. They can host your source files, and they can host your website, host your documentation, part of it. They can host the ticketing system. So let's go into a particular project here. We'll go to this particular project. The easiest way to support an open source project is not really just giving it money, okay? Because a lot of us do not really feel like giving other organizations money, which is fine. But one thing you can do is to report problems. So when you have problems, you can go to support, and you can basically report problems. When you use an open source product, you can say, okay, this feature is supposed to work like this. I tried it out, and it does not work like that. Instead, it crashes, or it does something else. You have to describe the problem, to make it as specific as possible, so that someone who is looking at your ticket, can figure out, okay, this is how we can reproduce the problem, and we can use that to help us debug the product and make it more bug-free. So that does not require any programming knowledge whatsoever. You're just reporting as an end user what you're observing, how the product is not working the way it's supposed to, so that somebody else can try to fix it. The other thing you can also do, once you become a proficient programmer, is you can try to download the source code of an open source project. I guess this is not it. You can download the source code of an open source project. You can look into the source code, okay? If the program is not working the way it's supposed to, and you really need that feature to be up and running, you can try to debug the product itself. And once you figure out, oh, I guess this conditional statement or the condition of the conditional statement really need to have a conjunction like this, and have some additional comparison, you fix it, right? And then you run it again, it seems to fix the problem, it's working for you. But that's only on your own desktop, on your own computer. So what you want to do next is to go back to the ticketing system, and then you can file another ticket, and basically say, okay, I'm reporting a problem, but I also have a patch for it. Now, you are not the maintainer of this project. So people who are actually maintaining the project can look at your ticket and say, oh, okay, this is the change, but it's not the way we want to fix this particular problem, so they can choose to do it in a different way. Or they can look at your patch and say, oh, great, somebody found the problem and fixed it already. We'll just incorporate your change into the main repository of the source code, so the next time this particular open source project is released, it will have your change incorporated into it. And you don't have to be a member of the open source project in this case at all. You're just contributing, a patch to fix a specific problem. Okay, so that's kind of interesting because I think a lot of times, people fix these problems not because they want to benefit everybody else, but because they want to benefit themselves. Okay, I need this particular feature working because I'm drawing a picture, a diagram of some sort, and I need this thing to be up and running. I don't want to wait for somebody to fix that problem if I have the ability to fix it, right? So I fix it, and then I upload it and just say, okay, this problem is now fixed with this patch. Please include it into future versions of the software. So I think that's really an interesting aspect of open source. It is not really socialist or communist. It's really just for your own benefit, but because other people are thinking the same way, it is benefiting everybody. So it's kind of a cool development model, I think. And we were talking about SD cards, stuff. And then we were also talking about how people can get to content on your hard drive even after you remove a file, after you delete a file, and after you remove that from the trash can also. Because when your disk head is overwriting a sector, it is not always aligned the same way. So there are software out there that can try to pick up residual magnetic energy that is not on the quote-unquote main track, but offset a little bit, so they can pick up files that was on that track or on that sector before, and be able to read files that you think was deleted and overwritten by another file. And we were talking about applications or utility software that can help you kind of remove even most of that residual part of the track. All right, so getting back to this class, we'll talk about the answer to the homework first, your nested homework assignment. So we'll go ahead and start with this one. I'm going to create a folder for today first. Did you guys have a nice break? Long weekend? Go to here, save the file, open it. All right, so here we have the original program. It's really not much more complicated compared to the example in the notes, the one that we actually went through in the class. This one has the one additional conditional statement inside the loop. In other words, from line 5 to line 7, we have one additional conditional statement inside the innermost loop. So let's go ahead and find out what this program is going to do, the behavior of this particular pseudocode. So let's resize. There we go. Right. All right. First thing first, we have to label all the columns. We got comments, line number, and then one column per variable. How many do we have? Two variables. We have variable x and variable y. I'll go ahead and change the size a little bit, even though it's not really necessary. We don't have a big, huge program to track in this case. All right, we'll start with the precondition. Since I did not tell you ahead of time that you can make any assumptions, you have to say that both of these start with some unknown value. Having an unknown value doesn't mean that they do not have a value. It simply means that you don't know what it is. Okay, so in this case, x may have a value of 513. It may have a value of negative 16. We don't know. We don't know what it is. So we just put a question mark to represent a value that we do not know. All right, we start with line 1. It overwrites the value of x with a constant of 1. We go to line 2. We evaluate the condition on line 2. X is less than 3 is true because x has a value of 1 at this point. Then we go to line 3. Y gets overwritten with a 0. We go to line 4. We evaluate the condition on line 4. y is less than 3 is true. We go to line 5. We evaluate another condition, y equals to 0 is true, because at this point, y, which is column D, has a value of 0. Then we go into the conditional statement on line 6, and we change y to 1. Then we get out of the conditional statement. Where do we go at this point?
Line 8.
We go to line 8. That is correct, because line 8 is a statement that is right after the conditional statement. Okay, so we have to go to line 8 at this point. And line 8 is going to increment y based on x. Y at this point has a value of 1. X at this point has a value of 1. 1 plus 1 is 2. We update y using that value. And then where do we go? We are at the end of the inner loop. So we have to go back to the beginning of the inner loop. The beginning of the inner loop is on line 4. So we now have to go back to line 4. Are we still doing okay so far? Okay. On line 4, we are re-evaluating the condition. Y is less than 3 is true because it has a value of 2 at this point. 2 is less than 3. We go back to line 5. Line 5 evaluates this condition, y equals to 0. It is now false. Then we go to line what? We go to line 8 again because we have to skip the entire conditional statement. Line 8 is going to add the value of x to y. X has a value of 1. Y at this point has a value of 2. 2 plus 1 is 3. So y is now updated to a value of 3. Then we go back to line 4 because that's the beginning of this particular loop. And we are checking this condition. Y is less than 3 is false at this point. And then where do we go? Exactly, we have to go to line 10 because line 10 is right after the inner loop. So we cannot just go all the way back to the beginning of the outer loop. We have to finish everything in the outer loop before we go back to the beginning of the outer loop. So now we go to line 10. We're adding 1 to x. X has a value of 1 at this point. It is now becoming 2. Then we can go back to the beginning of the outer loop, which is on line 2. Line 2 is checking what x is less than 3. It is still true. Then we go back to line 3. Line 3 is reinitializing y to 0. We go to line 4. Y is less than 3 is true because y has a value of 0 at this point. We go to line 5. Pretty much the same thing. Y equals to 0 is true because we just initialized it to 0. Then we go to line 6. Y gets a value of 1. Then we go to line 8. Y gets incremented by the value of x. X has a value of 2 at this point. Y has a value of 1 at this point. 2 plus 1 is 3. So y gets a value of 3 after only one update outside of the conditional statement. Then we go back to line 2, which is the beginning of the inner loop. Y
Go to
is
line 4 first, and it's false.
we go to
Oh, you said
You
two.
said 2 and typed 4.
oh, okay, sorry. Yeah, we go to line 4. That is right.
Yeah.
Yeah. So we go to line 4. Sorry. Professional liar, right? I type one thing, say another thing without realizing it at all. So the lie detector would not trip at all. It's like, oh, everything is normal. Just humming along. Okay, so y is less than 3 is not true anymore because y now has a value of 3. So we get out of the inner loop, we continue on to line 10, we add 1 to x, x goes from 2 to 3. We go back to line 2. Line 2 evaluates this condition again, x is less than 3 is now false. When the outer loop has false as a condition, we get out of the entire thing, we get to post, and that's the end of it. All right, so that's the trace of this particular homework assignment. I don't think there are any really tricky places because the code in the notes has similar features. There's one additional statement after the loop, so you kind of have to do about the same thing here. All right, so let me save the file. And and then we can go back to the topics that we are at right now. And let's save that to that. All right, so we are back to pre and post conditions. I think last time we already finished the loop, how to figure out the invariant of a loop. Did we finish the whole thing or not? Yes, no, maybe. I think we did. So once that we have finished the entire thing, we'll go ahead and try to combine all those things that we talked about. I did not click here because I can see the link is not highlighted. It's basically the same thing that we talked about in the class. The trick is how do we figure out the post condition? How do we figure out post 3 in this case? And in this class, I'm not going to give you guys the exact tool to do that because it's a little bit beyond the scope of this class. Okay? But once we know, or once we have a suspicion of what the loop invariant is, we can actually plug it in and see if it works out. And that worked out on last Thursday. So that's how we can figure out the post condition of the entire thing. I'm going to bring that up anyway, just to make sure that we finish the entire thing. So I'll use Notepad, bring up what we talked about on last Thursday. Okay. That's not it. Did we finish it on last Thursday? I should watch my own screen capture. Just to figure out, did I finish that or not? I thought I did. Sorry?
Finish that code.
Oh, okay, okay, we finished the post condition, but we didn't really combine everything to become the post condition of the entire thing. Thank you. Where did I put that? Okay, let me try to find out where I put it. We have a pre-post conditional. The data seems to be okay. This was just for conditional. Oh well. Should we redo the whole thing or not?
I think we
No.
ought to redo the whole thing. I think we ought to redo the whole thing.
We ought to redo the whole thing? Okay, let's redo the whole thing then. Yep.
You could just pull the last class.
Sorry?
You could just pull the last class and go through that.
Just replay the video, right? Yeah, just replay the whole playlist. Yeah, we can go through most of it a little bit quicker this time, but we'll focus on how to finish up the entire thing. Okay. So I'll keep this one up, and then I'll use Notepad to record the rest of it. All right, so let's go ahead and look at this. Not using a picture anymore because last time I think I used a picture, to look at the whole thing. And for one reason or another, I forgot either to save the picture. Let me just see if I can find it.
You saved it, 'cause I remember you saved,
Hmm?
you saved the picture.
Yeah, but I can't. Oh, that's the only picture I got is pre-post conditional.svg. That was the conditional. just figure out. Sometimes I save it in a different name. Nope, that's just conditional statement. It's not a loop. What happened to the one with the loop? I probably forgot to save it. It's all right. Okay, so let's go ahead and just work with this for now. Okay. On line 1, the precondition of line 1 in this case is true because we want to say that I want to know the end result of this code regardless of the initial value of x. So I don't want to make any assumption about the value of x before line 1 in this case. So I'm going to use true here. So I'll just kind of comment here. No assumptions about the value of x. Okay, as a precondition. I'm going to skip the reasoning or the rationale of deriving post 1 because that's not our main focus here. So I'll just say post 1 is x equals to 0 because that's the assignment statement. And there's nothing to forget either because the precondition is only true. It does not mention anything about x. Okay. Pre2 is the same as post 1 because the two statements are sequential. In this particular case, I can say they're sequential because from line 1, going from line 1 to line 2, it's only because these two statements are right next to each other. But from here, things get a little bit interesting because we want to figure out what is pre3. Okay, pre3 is a little bit interesting because I know that by the time we are about to execute line 3, the condition of the conditional statement, which is x is less than 3, has to be true. Because that's the only reason why we will get into a while loop or pre-checking loop and about to execute the statement. So we know that part has to be true. But something else also has to be true. Okay? I put this in parentheses because there are two ways to get to right before line 3 here. So I'm going to specify the format here, using a disjunction. The first part is saying, well, we may be getting into this loop the first time. Okay, if we're getting into this loop the first time, then pre2 is still true at this point because I do not have a chance to modify the value of x at this point. So pre2 would still be true at this point. On the other hand, this may not be my first iteration. It may be a second or additional iteration. In which case, post 3 has to be true because it's a loop. So the post condition of line 3 will have to go back and come back to the same point as a component of pre3. Are we doing okay so far with this code here? So this part, I'm pretty sure we covered already on last Thursday. And before I forget, I'm going to pass the bro sheet for today. Yep. All right. So the next step is to expand what is pre2 because we know what pre2 is already. Pre2 is the same as post 1, which is x equals to 0. We don't know what is post 3, so that part has to be remaining as post 3. And then we look at this, we go, can we do something about this? Because it doesn't seem to be very helpful at this point. Well, there are two ways to look at this. We can just leave it the way it is. And then we'll go ahead and try to figure out what is post 3. Now to figure out what is post 3, we use the same rationale as before. We look at line 3, and then we ask this question. Does the right-hand side of line 3 refer to the left-hand side? What is the answer? It does, right? Because the right-hand side is x plus 1, and then the left-hand side is just x. So the right-hand side as an expression does mention the variable that we are updating on the left-hand side. The next question, you have to ask the second question after the first one, is if we let f of x to be x plus 1, which is the right-hand side of the assignment statement, does it have an inverse function? Is there a way to reverse the effect of adding 1 to x? Yeah, we can just subtract 1 from x to reverse the operation. So if f of x is the right-hand side of the assignment statement, we have an inverse function of x minus 1 is an inverse. So as a result of that, we can use the substitution rule. The substitution rule says the post condition of line 3 is the result of substituting certain things in the precondition of line 3. In fact, we are replacing all occurrences of x with the f prime, which is the inverse function of the right-hand side, applied to x. Okay, and we can expand what is pre-3. Pre-3 is this mess here. So I'll just copy and paste it here. And we also know what f prime of x is. It is just x minus 1. So we have the post condition expressed like this. And then at this point, we were stuck on Thursday because the post condition relies on itself. So it becomes kind of difficult to resolve at this point. So on Thursday, what I said was, TAC proposes that post 3 is simply x is less than or equal to 3. That was my proposal. Okay, I was suggesting that this, if I plug this in, everything would work out. Okay, and we did that. Okay, so we did the substitution. So instead of just mentioning post 3 on both sides of the equality, I'm replacing post 3 with x is less than or equal to 3. And we want to find out whether it works out or not.
So that sub means substituting, right?
Yep, sub means substitution. And
Substituting post 3
Yep.
greater, less than 2, 3.
Yep. Every time we see x, we replace it with x minus 1. So now we take this whole thing, copy and paste it, and then we say this is now x minus 1. This is now x minus 1. And this one is x minus 1 also.
Substituting all instances of x is less than 3 with x minus 1.
That is correct. We are substituting everything, all the occurrences of x in the precondition of line 3 with x minus 1. Because what it is doing, what x minus 1 is doing, is undoing what line 3 had already done to x. So this is a way to revert back to the value of x before line 3, so that whatever we knew about x before line 3, we can maintain that relationship with that little tweak. Is that okay?
I'll get it eventually.
Because yep, go ahead.
This is somewhat similar but different. So basically, narrowing down a variable and an algebra equation.
Yes. It's similar to that. It's kind of like solving a simultaneous equation where you have things on both sides,
Equals, and you're just
to be the
kind of
same.
Finding the similarities and then seeing what you can substitute into it, narrow down the variable and substitute.
Right. Most of the time, the loop invariant is closely related to the condition of the conditional statement. Not conditional statement, but the condition of the loop itself. So in this case, you can see x is less than or equal to 3 is very similar to x is less than 3 with a little tweak of that additional equal next to it. All right. So the next question is, are these two things really the same? Can we somehow say that x is less than or equal to 3 is really saying the same thing as this mumbo jumbo here? That was the question. So now we can actually change this one and say that this is x is less than or equal to 3. Because x minus 1 is less than 3, if I know that x is an integer, it's really saying the same thing as x is less than or equal to 3. So that part is done. I did a simplification. And then the other part is basically saying, x equals to 1 or x is less than or equal to 3. And there's a conjunction here. X is less than or equal to 3. And then the other part, we have to deal with the disjunction first, the or. Yep.
Isn't for the second part x minus 1
Oh.
is less than or equal to 3? Isn't that x minus 1
Yep.
is less than or equal to 4?
That is correct. X is less than or equal to 4. Thank you. All right. So we have to take care of this or first. Okay. The next question now is, can we simplify this? Okay. If you want to answer the question, can we simplify this? Then you have to first ask the question: is one case including the other case completely. Yep, go ahead.
Where are you picking up the 4? I lost you when you brought
The 4 is coming from adding 1 to both sides of this. If I add 1 to both sides of this inequality, then we have x on one side and we have 4 on the other side. Okay, so the next question now is one case completely including the other case? That's the question. What do you think? In other words, can one imply the other one?
So you're trying to see if altering one variable will alter all other lines, right?
Not exactly. I'm trying to simplify this particular expression. X equals 1 implies x is less than or equal to 4, but not the other way around. Because whenever x is exactly 1, x is less than or equal to 4 is true. But if you just tell me that x is less than or equal to 4, it does not necessarily mean that x equals to 1.
So you want the less restrictive.
Well, I just want to figure out which one implies which one at this point. Okay, so we now know that x is less than 4 is more general compared to x equals 1. Now it makes sense too, because on the number line, how do you express x equals 1? It's one single dot on the number line. How do you express x is less than or equal to 4? You say, okay, from 4 and everything, on your left-hand side, right? So that means, x is less than or equal to 4 is more general, and it does include the specific case when x does equal to 1. This is a disjunction. A disjunction means, we want to use which one, the more general one or the more specific one? The more general one. So we can now simplify the entire thing to just the more specific, the more general one, which is x is less than or equal to 4. Now can we simplify this even more? In other words, does one side imply the other one? Well, one does imply the other one, right? X is less than or equal to 3 implies that x is less than or equal to 4, but not the other way around. Okay? So that means x is less than or equal to 3 is more specific than x is less than or equal to 4. But this time it is a conjunction. A conjunction is trying to make things more specific. So which one should I pick? X is less than or equal to 3 is the only one that is left. Well, now we have the post 3 being equal to the entire thing after the substitution.
Explain that again. How you lost x greater than 4? How did you lose that again?
Because this is a conjunction. A conjunction means the entire expression is true when both sides are true, right? Now, when do you think both sides will be true? When x equals 4, the right-hand side is true, but the left-hand side is false. But when x equals to 3 or less than 3, then both sides are true at the same time. So that means x is less than or equal to 4 is not necessary, because just by saying x is less than or equal to 3 is already expressing what we need to express. So after the simplification, we proved that post 3 is right, and this is where we left off last time. Okay, so tag was right about post 3. So now we can try to finish up the entire thing, which is post 4. The post 4 can be expressed with the following. The one thing that we know for sure is x. It is not the case that x is less than 3. Because if x was less than 3, we would still be in the loop and not getting out of the loop. So the fact that we are getting out of the loop means the condition of the loop has to be false at this point. But there are also other things we can say by the time we get out of the loop. It is possible, depending on the initial value of x before line 2, it is possible that we may not even enter the loop once. That is possible. So if we don't even get into the loop once, that means by this time, pre-2 still has to be true because we have not had a chance to modify the value of x. If we did get into the loop at least once, then post 3 must be true also at this point, because we have gone through the loop at least once. So after line 3, post 3 is guaranteed to be true. Next, we'll try to simplify this. It is not the case that x is less than 3. It's really saying the same thing as x is greater than or equal to 3. Is that part okay? Turning the negation into, just tweak the comparison so we can get rid of the negation. And then we try to work out the other part. Pre-2, if we look up here, pre-2 is the same as post-1, which is just x equals to 0. Post-3 is x is less than or equal to 3. So now we have the entire expression looking like this. So the next question is, can we simplify the disjunction? I will highlight that part, and you can tell me how we can simplify this. First of all, does one case completely include the other case?
Yes.
X equal to 0 is a specific case of x is less than or equal to 3. But since this is a disjunction, we have to pick which one, the general one or the specific one? The general one. So which one is more general? X is less than or equal to 3. So the entire expression gets reduced to just x is less than or equal to 3. Is that possible? X is greater than or equal to 3, and at the same time, x is less than or equal to 3.
Yes.
It just means that
X is 3.
x is 3, exactly. That's it. That's the post condition of the entire loop. So what, after all this mumbo jumbo, we arrive to the conclusion that x has to be the same, has to be 3 when we get out of this loop. Now someone can argue and say, yeah, but we can get to this conclusion just by tracing the algorithm, right? That's something that we could do, we could have done. Well, we could not have done a trace if I had replaced this 0 with k and replace this 3 with m. In other words, in that case, they're both unknown. How can I say something? How can I trace an algorithm when I don't know what k is or m is? Okay, so once again, I'm using concrete value here, so it's easier on us to try to figure out and see how it is done. But the value of using pre and post conditions instead of tracing the algorithm is we can come to a conclusion and we can say something definite without even going through the algorithm once as using a trace. Are we doing okay so far with this? Okay, very good. In the tests, I will not ask you questions about loops because it really is a little bit tricky. And for this class, we are not going to deal with loops with post and pre and post conditions. But I do want to expose you to it just so that you know that the pre and post condition derivation can be applied to loops as well. Okay. Any questions about this particular topic? Officially, this is called algorithm verification, or software program verification. It is a big topic in a discipline called software engineering. It is supposed to be the holy grail of program verification, because if we can make this mechanical and implement this using computers, then we can potentially have a program to verify the correctness of another program. Now that is great, right? Because if you can express, the condition of an array, well, we haven't really got to arrays yet, but if you can express the correct result of an algorithm using mathematical terms like this, and the other program can look at the source code of one program and come to the same conclusion, then you don't have to take, darts anymore, because you don't need traces to give you a warm and fuzzy feeling that the program is correct, because you know the program has to be correct. Okay, so that particular topic is called algorithm or program verification, and you can look this up and figure out, read about it too, if you want to. So algorithm verification. Maybe more general, using program verification. Formal verification, that's it, that's the topic. And many of you probably won't encounter this again until you get to graduate school. Or they have a class called algorithm analysis as an upper division class in a 4-year university. That's when you will encounter something like this again. Any questions? This seems to be extremely boring. Do you think it's useful at all? But the Holy Grail cannot possibly be useful because nobody has it, right? So why do you think this topic is still important, even though it is not, at this point anyway, at this point we don't really have the ability to automatically verify long programs. For short ones, like the ones that we just dealt with, yes, okay, even a computer can deal with that. But for something that's complicated, we definitely do not have the ability to verify the correctness of an algorithm. So why is this topic even important when it is not feasible, based on the hardware that we have at this point? Yep. Well, if we just give up, then definitely there won't be any progress, right? But there's actually a more pragmatic side to this, because the same reasoning that we apply to analyze a program to derive the pre and post conditions is the same kind of reasoning that we can apply when we are debugging a program. When a program is not behaving the way it's supposed to, and we want to find out why it is not doing that, it is exactly the same type of reasoning. We're just applying in a different way to analyze a program from the bottom up instead of from the top down. All right. Very good. So we have pretty much finished up the entire topic of your pre and post conditions. Do we have any questions at this point? Yep.
On the test, the exam, are you going to be on the computers or are you going to be written?
It'll be written because the lab doesn't have enough room for this class. We still have about 40 students in the class, so we cannot go into the lab and use the lab. So that's a good question. It brings up, when are we going to have the first exam? Because right here, after pre and post conditions, we have practice exam 1 and exam 1 archive. Those are all previous exams. So we are going to schedule the exam. Let's see, we can have a practice exam on Thursday. So next Thursday will be the actual exam. Okay. So let me put it on the calendar first so that we remember that. Turn on editing. So this is really just a calendar event. It's not actual because we cannot use an online test with this class. So I'll just put something in the calendar. All right, today is the 19th. So next Thursday is going to be the 28th.
That's going to be our test day. Is that going to be our exam day?
Yep, that's going to be the day of our first exam. You want to add an event, so new event. I'm putting this in Moodle, so next time you log into Moodle, this will appear in the recent event. Yep. So we'll just say exam 1. And it's going to be on the 28th. The time is 10:30. And it will be on paper, so you just have to bring a piece of, okay, I'll tell you exactly what to do here. Okay, I'll use this particular method to make sure that I cover everything that I need to cover. Okay, there we go. All right, first thing is open book, open notes. That means you can print out anything you want and bring in anything that is handwritten as well. Okay, you can bring, if you want to bring in tons of books with you, that's fine. If you want to print out all the notes that I have written, that's fine. If you want to print out all the sample programs that we worked on in the class, that's fine too. Okay, so it's open book, open notes. Okay, anything that is printed or handwritten prior to the exam. You can even study together and come up with notes that you want to bring into the class. Okay, that's fine with me. Studying together actually is helpful. Okay, for the most part, as long as all members of the group contribute and try to solve problems and explain things, it's actually it's better than studying by yourself sometimes. Okay, no electronics, which means no cell phone, no laptop computer, tablets, or that sort of thing. Okay, I can guarantee, not almost, I can guarantee that any type of computation you have to perform will be single digit addition. Okay, I'm hoping that you guys are okay with that without a calculator. Yes? All right. So no electronics. Brain writing equipment. Okay, so pencil, pens, erasers, PC. Okay. Because I know some of you, do not bring anything to the class, normally, so on that particular day, next Thursday, you want to bring, your own pen or pencils, okay, just to make sure that you don't have to borrow it from somebody else. Bring additional paper. I will give you the exam to write on, but if in case you think you need additional, paper, you can bring additional binder paper if you want to. You can bring your binder. I mean, if you take notes normally using a binder, just take that whole binder, and if you have blank paper, pieces of blank paper in the binder, you can use that too. I think I will give you enough space, for all the scratch work, that you need. But in case you need additional paper, you might want to bring some additional paper. I think that's it. I mean, it's not a group effort, so you are supposed to work on your own exam. I don't know. What else? Do you want to ask any questions about the format of the exam? We'll be here just like today. The exam will start exactly at 10:30. It'll be 80 minutes. Okay. So that means we'll start at 10:30 a.m. and it will end at 11:50 a.m. Just like the usual class period. Any other questions?
Can you show us one of those examples?
Sorry?
Can you show us one of those examples?
Yes, we will. And that's what Thursday is about. Well, we'll do some of those today, but we'll also do some more on Thursday. And that's why the exam is scheduled on next Thursday, because I always want to give you one more day of class meeting, like next Tuesday, to ask any additional questions. Yep.
Most students don't take 80 minutes to go through the test, correct?
That is correct. For various reasons. Some people just kind of gave up and go, nope, okay, just walk out of the classroom. No, most people can get it done, before the time is up. There are people who will use up all 80 minutes. I mean, it's fine too. There's nothing wrong with that too. If you're done early, you can just you can get out of the classroom early. Just turn it in and you're done. Any other questions?
About how many equations do we have?
There will be at least one pre and post condition question, and then the other ones will be traces. But I have found that grading trace questions is really kind of difficult. It's not difficult from the perspective of looking at the trace and find out whether it's correct or not. It is when it is not correct. Should I give it any partial credit? Because some people make a mistake really early on, and then everything else after that is messed up. So the question is, well, but if it is consistent, okay, if everything else, after that point of error is consistent, it still kind of show that person understand the material. It's just one stupid mistake early on. So it makes grading really hard. So I'm still trying to figure out what would be the best type of question to ask. So it's easy on me for grading, but it's still fair on you guys. So that if you understand a particular concept, you still get points for that. And I find it's really hard to ask. It's really hard to find questions of that kind. Yep.
The contents of the exam archive are included in the open notes thing, yeah?
Yes, you can bring past exams to this particular exam if you want to. Yes. In fact, you can go back and look at and watch the YouTube from past semesters about exam 1, especially the ones after exam 1. Then you can actually see what kind of question I can ask and what are the answers of those particular questions. I think I might have about 4 semesters worth of a recording online already. Yep.
Instead of doing full traces, could you just do a partial trace? Where like there's a trace in progress, you have to fill in where
Right,
it's missing.
right. I think that would be the best option. But then I need more questions, because each one is going to be a pretty short one. So I'll have to ask, a little bit more questions. But that's probably the best way to do it, is to give you a trace up to a certain point, and then you have to continue the next 2-3 lines or so. So this way, I'm still testing whether you're careful or not. But if you're not careful, it's not the end of the world, because it's really just partial points of one particular question, and there'll be more questions. But tracing will definitely be one of the topics that I'm going to test. All right, so I'm going to save this. If I find anything else, we can always do that later. That's the date without duration. We'll just put a duration here of 80 minutes. So this way it's complete. Save changes. Now we have it on the calendar. So when you log in and you go to upcoming events, you will see exam 1 on your upcoming events. If you look at the calendar, the 28th will have exam 1 also. Okay? It's a reminder. Okay, we're still taking the test on paper. It's just a reminder that we have here. All right. Yep.
Are we going to need a ruler to do the traces too?
No, because I'm going to give you everything in a table in a grid format already, so you don't have to bring your ruler. It doesn't hurt to bring your rulers if you want to. I mean, it definitely is going to be helpful if you need it. All right. So let's go ahead and take a look at past exams. Well, we'll take a look at this one first. This one is a PDF. Can I open it by itself? Yep, there we go. That's not the right one. I want this one. Yep.
Mouse over the bottom right hand corner of the document itself.
Mouse over.
Bottom right hand.
Sorry?
The bottom right hand corner.
The bottom right
Yeah,
hand.
just where it is. The toolbar. Bottom right hand corner.
Ah, okay.
A little distant.
Great, excellent. All right, so we have a few questions here. Question number 1 is code tracing. Now, once again, the format of the question may not be the same as what you're seeing here. In other words, I can give you the source code, I can give you a partial trace, and then I'll ask you for the next 3 lines or the next line. So you only have to complete a partial trace, but there will be more questions because each partial trace doesn't take that much time. So you will have more partial traces to deal with. Okay, so in this case, it's a full trace, 20 points allocated to it, and I have certain assumptions, assuming x equals to 300 and y equals to 98 before the algorithm starts. So let's go ahead and give this one a try. And I'm going to make this a little bit bigger so we can see the algorithm better. Since I'm doing this in the class, I can use the usual way of doing it. Oops. I'm going to rewrite the algorithm in the spreadsheet first, and then we'll trace it in the spreadsheet. If x is greater than y, then while y is less than x, do y gets y plus 1, while x gets 0. If, all right, so we algorithm here. Should I do indentation, or are you guys okay without indentation? That really shows the importance of indentation, because without indentation, we can still kind of figure out what the algorithm is, but it's really harder to figure out, okay, this is the end of what, where is the beginning of the same thing? And this is only like 6 lines. Imagine your algorithm, your subroutine, in the C and C++ class being 30 or 40 lines, and you have no indentations whatsoever. It becomes really hard to figure out what is the beginning of this, and vice, and stuff like that. All right. And there are some assumptions here. So let me go back to this. The assumption is, the assumption is x equals to 300 and y equals to 298 before the loop, or before the pseudocode. So let's go back to here. Use a new window for the trace. Sheet 2. We have comments because we have conditions to evaluate. Line number, we got x and y. X starts with a value of 300, that was the assumption. And y starts with a value of 298. That's part of the assumption too. That's our precondition. All right, so let's go ahead and get started on line 1. Line 1 has to evaluate the condition x is greater than y. Is that true or false? True. It's true. Then we move on to line 2. Line 2 is the beginning of a while loop. It has its own condition to evaluate. Y is less than x is true. Okay. Then we go to line 3. What does line 3 do? It updates y, so y goes from 298 to 299. And then where do we go after that? We go back to the beginning of the loop that we are ending at this point. There's only one loop, so we have to go back to line 2. Okay. Y is less than x is true because y is 299 and x has a value of 300. We go back to line 3. We add 1 to y again. Y goes from 299 to 300. We go back to line 2. Y is less than x is now false. Very good. And then where do we go? We go to line 5 because line 5 is right after the end while. So we go to line 5. Line 5 is going to make x 0 again. And then where do we go? We're done. Yep, that's it. Is this algorithm correct? That's a trick question. We don't know because I didn't tell you what it is supposed to do. So if you don't know what an algorithm is supposed to do, you cannot say whether it is correct or not because there's no comparison to say, oh, okay, I compare the expected outcome of the algorithm with the actual outcome of the algorithm. They are the same and therefore it is correct. But if I don't tell you what it is supposed to do, then you cannot really say whether it's correct or not. Are we doing okay so far with this particular sample program? Okay. So the most important part here is to differentiate what is a conditional statement versus what is a loop. With a loop, there's a chance that you can go back to the beginning. Well, with a pre-checking loop, there's a chance that you can skip the entire thing because if the condition of the if the condition of the loop is false to begin with, you do not even perform the iteration once. But with a conditional statement on the outside, there's no way you go back to line 1 because it is a conditional statement. When you're done with the branch of a conditional statement, you get out of the conditional statement. And in this case, there's nothing after the conditional statement, so you get to post right away. Are there any questions about this particular sample program? Questions?
I have a question.
Go ahead.
What is that algorithm supposed to do, and is it correct? What is that algorithm supposed to do, and is it correct? I'm curious.
It's really just a question, so I did not really even think about what it is supposed to do. In other words, it is kind of meaningless. The algorithm itself is kind of meaningless. It's just a question, and nothing more than that. All right, so that's question number 1, and here's question number 2. Question number 2 says, step by step with explanation, derive pre-2, pre-4, post-2, and post-4, post-4 and post-5, assuming the following. In other words, in this case, I have a conditional statement with a then and an else. I give you the precondition of line 1. I want you to tell me what is post 5, but not just post 5. I want you to tell me exactly how to derive post 5 line by line and giving me all the rationale in between. Okay, so that's the nature of the question. So this one I'm going to use Notepad or Mousepad because it's really is just derivation. It's not a trace. So the one thing you want to do and make sure that you understand is when we work with pre and post conditions, it is not tracing the algorithm. In this case, there's no way to trace it because I'm not even telling you what is J and what is K. And without knowing what is J and what is K, there's no way to trace the algorithm. We can only use pre and post conditions to say, okay, if we know this is the precondition, then we know that has to be the post condition. All right. So we'll go ahead and start with this one. So pre-1 is already known. You don't have to restate pre-1 because it's already given. I just like that because I like to have the entire derivation written here. So my preference is to derive pre-2 and pre-4 and then post-2 and post-4. You don't have to follow that order. Some people like to derive pre-2 and then post-2 and then pre-4 and then post-4. That's just as good. So pre-2 is pre-1 and x is greater than y. Okay. Now it is very important. It is very important that you mention pre-1 here because there's a reason why that component is here because we don't have a chance to modify x or y at this point to get to this point, and therefore whatever was true in pre-1 still has to be true at this point, and that's why it is important to use pre-1 instead of just substituting pre-1 with the actual condition. So after that, we can expand what is pre-1 and finish pre-2. My personal preference is to work with your pre-4 right away because it is pre-1 and not x is greater than y. There's a symmetry to it. And that's why I like to work with pre-2 and pre-4, right next to each other. It may not be your preference. You don't have to do it the same way that I do it. And in this case, x is not greater than y means x is less than or equal to y. Do we have any questions at this point about pre-2 and pre-4? Yep, go ahead.
So when you're saying pre-1, you're meaning pre-1 line. You should be rewriting it there, then you're adding together, and then you're branching it out underneath.
You mean here?
Yeah.
Yeah, this line is just repeating a portion of the question itself.
Doing it like pre-2.
This one here?
Yeah.
Yeah, this one is important because it's relating pre-2 to pre-1 and also the condition of the conditional statement.
So the word pre-1 is just reference up to one of those.
That is correct. So pre-1 expands to whatever it is in the second step. But I don't jump from, I don't combine these two steps into one because it is important to restate, this is actually pre-1. Okay. So after this, I can approach, post-2. Okay.
I'm so confused why you have to put pre-1.
Sorry?
I'm so confused why pre-1's there.
Why pre-1 is there? Because whatever is true before this line, if you look at this line here, pre-1 is saying what has to be true before this line, right? Now when we look at, let's say, pre-4, okay? Pre-4 is saying what has to be true right before this line executes. Well,
Because
between
it comes off of line 1.
exactly. Between this line and right before this line, I do not have any opportunities to change x or y, and that's why pre-1 still has to be true before line 4 executes.
Yeah, that makes sense. I'm thinking of it like more sequentially, I guess. Like everything has to go in order, and that just refers back to line 1 instead of.
Right. To look at this, it's better to look at it as a picture, because you're branching out into two possible branches, and we are asking, what has to be true before the action of each branch. So Now we can work on the, I'll just work on the post 2 at this point. Now to understand how to derive from pre-2 to post-2, it doesn't matter whether it is in a precondition or not, in a conditional statement or not, because in this case it's just an assignment statement. So you have to use the rationale of the right-hand side of line 2. Does it refer to the left-hand side or not?
No.
No, it does not. Okay, so you can say does not refer to the left-hand side. If the right-hand side does not refer to the left-hand side, that means it's not reversible. There's no way this operation is reversible in any way. If it is not reversible, then all you can do is to use the forget rule. Okay, use the forget rule. And to use the forget rule means the post condition of a line is based on the precondition of the same line, but you might have to delete or remove certain components of it. In this case, what should I be forgetting? Things that include X or things that include Y?
X.
Which one is being changed?
Why?
Y is being changed, so that's why I need to forget about things that I knew about Y, because some of those things may not be true anymore. But in addition to whatever is remaining from pre-2, I also know one thing for sure. I know X and Y have to be the same at this point, because that's the effect of the assignment statement. So we start with the forget rule. We start with the rationale of using the forget rule. We then move on to the template of a forget rule. And then we can work out the details, because we can then use what is pre-2, pre-2. Now this is a whole lot easier for me because I can copy and paste. Yes?
Can we say, should that be y equals x and y equals?
It doesn't matter, it's symmetric. So
Yeah.
if you want to say it this way, it's just as good. Okay, so I have to specify, components that contain Y have to be removed, and Y still equals to X. And then the next line, I carry out the actual forget operation. X equals J does not mention anything about Y, so that's still good to go. The other two I cannot hold anymore, because Y equals K may or may not be true anymore. It depends on what the value of J is. Okay, but I didn't tell you that J and K are the same, so I cannot retain that particular fact anymore. The fact that X was greater than Y cannot be retained either, because I don't know the relationship between J and K. So the only thing I can keep from pre-2 is just that X equals to J, and now I can say Y equals to X. But remember, we want to push this one step further and basically say that Y equals to J. In this case, it doesn't really matter one way or another, because J is another variable. So whether you make this statement or not doesn't really change a whole lot.
Question.
Yep.
Don't you know that x is greater than k as well?
That's true. Yep. In this case, yes. Good point. Very good. But in general, we cannot keep that fact. Yep. Good comment. Does everybody get that part? Okay. The fact that we knew that X was greater than. Okay. The fact that we knew that X equals to J, and Y equals to K, and X is greater than Y. We can use this to infer that J is greater than K. That is true.
Pull that out a little bit so I can see what the last y.
Sure. Okay. Let me do this. Let me scroll this one to the top, and then we can reshape this one like so. This is the kind of thing that I cannot easily do with a regular whiteboard. So you are absolutely correct. There is one more step that I could have performed before this, before I do the forget operation, so I can still retain that J is greater than K. But using the mechanical method that we talked about in the class, we kind of lost that information. Okay. Any other questions about this one? Okay, so we have post 2, and now we can work on post 4. Now post 4 is a little bit different because the right hand side of line 4 does refer to the left hand side. Now just because it refers to the left hand side doesn't mean that we can use the substitution rule. We have to make sure that it is reversible. Okay, so we can say the right hand side of line 4, f of x is x plus 1, has an inverse. F prime of x is x minus 1. Now because there is an inverse in this case, we can use the substitution rule. Use the substitution rule, or just use the substitution rule. Go. So that means the post condition of line 4 is based on the precondition of line 4, but we have to do some tweaking using the substitution operation. So we substitute whatever is in pre-4, whatever contains x, we want to change that to f prime applied to x. So the first line here is the template, and then we can expand it. We look at what is pre-4, we copy and paste that here, and then x is just x. F prime applied to x is x minus 1. And all you have to do is really just to replace x with x minus 1. It's perfectly fine to say x minus 1 equals j, and y equals k, and x minus 1 is less than or equal to y. That's perfectly fine. So now we have post 2 and post 4. As far as post 5 is concerned, you want to mention post 2 or post 4. Now this line is significant. Let me pull this up first. This line is significant because it is telling me how line 5 relates to post 2 and post 4. In other words, it is structural. It is because of the structure of a conditional statement that I can mention something like this. So that's why I don't want to just I don't want to just give myself the final result. I want to kind of explain why that is the case. So the result is, in this case, just copy and paste it here. This is post 2, and this is post 4. And that's the final answer. So you were right that you could have retained the relationship between j and k, but that is not required because we never really mentioned that in the class. Are there any questions? There's no need to do simplifications. There's no need to simplify this to become x equals to j plus 1 because we're not gaining any information by changing the representation here. All right, is that good? Okay. So let me make sure I save this file. Save into this folder. And this is exam1q2.txt. One of you can remind me to upload this folder so that you can actually get the files that we were capturing earlier. Question 3 is to trace the code of question 1 again, but this time assume x equals to 300 and y equals 300 before the algorithm starts. Instead of actually tracing it again, I'll just ask you what happens, okay? Because it's so simple that it doesn't really worth. It's not worth the time to set up the spreadsheet again. Okay, so this time I want you to retrace the algorithm in question number 1, except the precondition is x equals to 300 and y equals to 300. What is going to happen this time?
Post.
We still have to go to line 1, okay? So in the trace, we still have to go to line 1. The condition x is greater than y is false, and then we exit the conditional statement right away. We skip everything, and then we get to post right away. In other words, the entire trace will consist of pre, 1, post. Okay. Does everybody understand the trace of this particular algorithm given that x and y both have the value of 300? Okay. So down to question number 4, reverse reduction. Okay. So in this case, we are given that for some constant k, the post condition of line 3 is given to you to be something like this. I want to be able to reverse everything and try to figure out what is pre-1. Okay? In other words, I find that the program, may not be working correctly. By the time, I'm done with line 3, I can see this, and this is not the condition it's supposed to be. I want to find out how it can get to this point. In other words, I want to reverse everything back to pre-1. That's the, that's what this question is asking. And then if you read the question itself, we won't have enough time to finish this, so we'll finish this one on Thursday. Step by step and sequentially deduce and explain the precondition of each line. So you want to start with pre-3, then you move on to pre-2, and then you want to move on to pre-1. While you do not need to use formal mathematical proof, you still need to kind of briefly explain each step of your answer. So you kind of have to tell me why you think pre-3 is like this when post-3 is like that. Why do you think that you can make that derivation, or you can infer that pre-3 is like that? Now, I don't have enough time to finish this question because this one is a little bit longer. I do want to show you, for those of you who want to kind of do this ahead of me, I want to show you how to get to the question, of the other one, the other test. There are two pre-tests. We were talking about the practice test, practice exam 1, which was actually one of the exams. Okay, this was not just a practice test; it was the actual test in one of the years. You can read the first page to find out exactly when, and try to locate the screen recording, right after that particular date. Then you can actually see the answer of the whole thing. This one is an archive file. It is, okay. When you click it, it will download a tar.gz file. Windows doesn't know how to deal with this file natively. What you want to do is to install 7-zip or WinRAR, or some of those, decompression tool, and those can decompress this file. It will separate it into individual files. I think there's one file per question, so you can actually look through those questions and try to figure it out. We'll talk about it on Thursday. So, do you mind if I let you guys out like 3 minutes early? I promise you I'll make it up. We'll make it up into the last class. The last class is going to be half an hour over.
I'll hold you to making up these 3 minutes.
That's fine, it's recorded. Otherwise, you can ask the college for a refund.